1. You should know what the general shape is. So if this goes like this, secant goes up, it's that U-shaped thing, right? And it has these asymptotes. Where do those asymptotes occur? Like, what is this? It's pi over 2, right? Pi over 2 in decimal numbers is roughly what? 1.50107, you know, it's half of pi, right? So if we're going from x equals -1 to 1, are we going to go past that asymptote? No, we're not. We're bounded by that asymptote. So you're looking at x equals, let's say -1 is there, and +1 is right there. And you're also bounded by y equals 1. So y equals 1 is right there. And then it goes up to here, and it goes up like this. So here's this region that you have, right? Everybody sees that region? What are you doing with that region? You need to draw the reflection. So if you draw that reflection, which is pretty nice to draw on this, I'll change the color. You end up with... Is that a parabola? Is it exactly a parabola? No. It's one thing I made a mistake of several times. I remember this in high school math. I would try to model things instead of using a curve, instead of using a parabola or like a circle. You know, circles, parabolas, and trig functions, are they the same curvature? No. Are they similar? Yeah, they're similar shape, but they're not. So there's your reflection. What do you draw next?
The washer.
You draw the washer, exactly. So let's do the slice right there, and then you connect like this. So there's your washer, right? What do you notice about this function? There's one key thing you could notice about this function that helps you a little bit when you're doing this. It begins with an S, S-Y-M. This is symmetric. This is an even function. So instead of going from -1 to 1, what can we integrate from? 0 to 1 and just double it, right? And it's going to be 2 pi times the big radius squared minus the little radius squared dx, right? Why is it dx and not dy?
Because it's
What is? The washer perpendicular to the x-axis, exactly, right. And in this case, let's draw the actual radiuses in. We know that, and I'll get the right color here, this right here, sorry, from there to there, that's the big R, and from here to here is the small r. Do you agree with that? So what is the big R in this case?
It's going to be the 1 over cosine.
Which is just secant x. Leave it as secant. That's correct. And what is little r?
Y equals 1.
Y equals 1. Just 1, right? Just the distance. It stays at 1, right? Everything needs to be in terms of x. We're cool with that. And 1 is a constant, so it's okay. So we have 2 pi times the integral from 0 to 1 of secant squared x minus 1 squared, which is just 1 dx. Let's just pause here and take a look at this. This is not something we haven't done this yet, but the success of this, which is really important right here, is totally reliant on something. So please clear your desk of everything besides a pencil. Let's say this function right here is y equals x. Are we integrating with respect to x or y? We are integrating with respect to y. It's going to be the integral dy, correct. Now, how many integrals am I going to need to use to do this one? 2. You're going to need 2 because the outer radius right here, the outer radius stays the same right there. But what happens to the inner radius? Here's the inner radius, and then what happens to it? It changes right there. So you need 2. The first one is going to start at 0 and go to 1. And what's the outer radius equal to? Oh, let's just say, yeah, you're right, 4, 2. You're absolutely right. 0, 2, 2, correct. It's going to be pi. And what's the outer radius? Oh, yeah, I got to give you a scale, don't I? What is it? It's 4. And what's the inner radius? Great. Okay. What's the second integral? 2 to 4. And what's the outer radius? Still 4, but what are you subtracting? Not x squared. Y squared because it's dy. Because it's the radius, it's x equals y. Are we okay with that? Okay, I want you to take 2 minutes and by yourself, everybody, by yourself, please integrate and give me a final answer in exact improper integral form, improper fraction form. You understand? Fraction form should be pi, no decimals. Find me the answer. What is this distance called right here? What is that?
2 pi.
Or no, the circumference.
The circumference. Is it ENC or ANC? Circumference, right?
E-R-E-N-C.
Like this? Okay, so circumference, do you see how that's built right there? So let's say we are at this distance of x, and we're going around. If we were at x, that would be the radius of that circle. So circumference is usually written as pi times diameter, which is the same thing as writing 2 pi r. So if you have 2 pi r dx and the height here, we'll call it h, how do you find the volume of that particular rectangular strip? You multiply them all together, right? So each piece is going to be 2 pi r times the height dx. And we're integrating that from, in this case, let's say it was 2 to 4, whatever the lower bound and the upper bound is. So we're gonna mix the general and the specific in this one. So in this case, we're integrating from, what can we factor out to the outside? Well, we can definitely factor out 2 pi, right? It's 2 to 4 of RH dx. Are we okay with that? In this case, what is the radius? It's x. The radius is x, because now the radius is not going from bottom to up. The radius for this is going from, we get a different color here, from here to there. What is that distance? That is x. So now we have 2 pi, 2 to 4 of x. What's the height of this function? The height is right here. What is that height? Yeah, that function x, right? Integrating with respect to x, so you're right. H in this case is, r is x, and so is, we'll pause in a sec. We'll pause, hold on, go on. Yes, go. You're doing the integral of 2 pi from 2 to 4 of x squared dx. What's the integral of x squared? 1/3 x cubed from 2 to 4. So that's 2 pi times, and if I can get this, 64 over 3 minus 8 over 3, which is going to be 2 pi times 56 over 3, which is 112 over 3 pi. Was that a cleaner method? Yeah. First of all, the difference between the difficulty levels here is not huge. It exists, though. You had to do 2 integrals before, and there were more nasty fractions you had to deal with. This one, less fractions, quicker, and it seemed a little simpler. The other key thing to realize is, how many integrals did we have to do for this method right here? 2. How many integrals did you have to do for this one? 1. Not only was this integral easier, it was just one of them. Yeah, Mariah. You're taking this, you draw one rectangle right here, and you draw the mirror rectangle right there, and then you just connect them as carefully as you can. And does that go all the way around? Yes. Everybody sees that right there? Are we integrating this with respect to x or y? Definitely y. So this is the integral from 0 all the way to what? It's a pretty easy one. 1. I set it up that way. And it's always going to be 2 pi, the radius times h, and this is dy. Correct? What's the radius in this case? This is the radius is the easy one to get in this case. Nope. What is the radius? The radius is, it's y. The radius is this distance right here. The distance from the x-axis all the way up to how high you are. How high you are is y. That would change if we weren't rotating around an axis. We'd have to add or subtract something to x or y. But we're still rotating around an axis here. So in this case, what's the radius? It's y. And what's the height going to be? We have h dy. The height is this distance right here. You see that distance? Does it have to be in terms of x or y? It's got to be in terms of y. So we need to write everything, we need to write it a little differently. What is that? That is x equals plus or minus the square root of y. And this is x equals y squared. These are positive right here. Those are positive y values, so you want the positive one right there. So the one that's above in this case, or to the right, is the red one. So can someone tell me what the height is going to be on this one? Square root y minus what? Y squared. Exactly. Does everybody see why that's true? So we have 2 pi integral from 0 to 1 of y times the square root of y minus y squared dy. Is that particularly challenging to integrate? Not really. That's just undoing the power rule. That's just undoing the power rule. This right here is going to be very similar to if we did this one with washers. So in this case, there isn't really too much of an advantage either way. Can you just tell me, by looking at it, what the equation is going to be for washers? It's going to be pi. Are we going to do dx or dy for this? It's going to be dx, and it's going to go from 0 to 1 again. What's the outer radius in this case? No, it's in terms of x now, right? It's root x squared minus x squared squared dx. Now here's the thing. In this case, which one is going to be easier to integrate? That one or that one? This one looks a little bit easier to integrate because you're going to get rid of that square root by squaring it. So it's about the same. They're just different ways about going about the same problem. You just need to recognize sometimes one will be easier than the other. And sometimes you'll be prompted, use cylindrical shells here. 2 pi? How many of you got 2 pi? Can't be negative. 2 pi? Yeah, 2 pi. Good. Okay. So that's nice. But what happens if you try to do it with slices? So with washers, what's it going to look like? Instead of that, you're going to have these, right? You have the same shape over here, poorly drawn. I got it. But it looks like this, correct? Like there it is. Yay. So for this one, you need pi from 0 to, well, you don't know what it is because it's going from, do you know how high this is? You don't know yet. You have to figure that out for one. And then it's going to be the radius squared minus the little radius squared. Is it dx or dy? dy. Okay, so we know that y is equal to sine of x squared, correct? So what do we need to isolate? X. How do you do that? What do you have to say? X squared is equal to the sine inverse of y. So x is equal to plus or minus the square root of sine inverse of y. Okay, that's nice. What that means, though, is that one of these, this section right here, is 1/2 of that function, and this right here is the other half of that function. One's the positive and one's the negative. Does it matter if we're subtracting them? So one of them's the outer one and one of them's the inner one. How do we figure out which one that is? Any ideas? So I guess the baseline is when you get to this, you should think, ooh, I don't like it. And we also, the other big problem is this right here. We don't know how high it is, and you really don't have a good way yet of doing that. You don't wait yet, because you'd have to find out where the rate of change is 0, right? So if you're going to do that, you have to set up, well, hey, you know how to do that, kind of, right? Yeah, you know the f of x is, n of x squared, right? So what's f prime of? So it's 2x cosine of x squared, correct? And you want to know where that's equal to what? So 2x cosine x squared is equal to 0. And that's definitely where it's equal to 0, but we don't want that one. We know the derivative is 0 there. Great. We want it when cosine x squared is equal to 0, right? So that's, how do you solve for that? X is equal to, so x squared is equal to what? Cosine inverse of 0. When is cosine 0? So x squared is equal to pi over 2. So x is equal to plus or minus the square root of pi over 2. So we actually figured that out. Okay, so we're still plugging along. So are we still, it's the square root over 2. It's not that bad, but is this a lot worse than what we just did? Yeah, you could hammer away at this, but no.